Good morning, you guys. Sorry, this is not how I wanted to do things. I have COVID, so I will not be in school for a little bit. But I did want to do, this is really the last thing that we're going to be doing for class. So I'm just going to try to go through the lesson with you this way. And but like I said, this is the last new thing before the final, before the Unit 4 test, and then before the final. Actually, no, there's one more thing before the final. I lied. Anyway, so today is all about putting it together. We have been doing graphing of quadratic equations, and we have been solving quadratic equations, but now we're going to put the two things together. So remember with parabolas. Parabolas have that U shape. And there's key characteristics that are going to help us graph this. So the key characteristics, whether it opens up or down, the vertex, the axis of symmetry. Now, before I showed you how to find other points on the graph, and that still works, but now that we know how to solve equations, what we can actually do is we can find other points also by focusing on the intercepts. So there's the y-intercept and the x-intercepts. Now, really quickly on the x-intercepts, actually on both intercepts, you're always going to have at least a y-intercept, and there's only one. You're always going to be able to hit that. Remember that parabolas go forever to the left and to the right. The domain is always going to be negative infinity to positive infinity for parabolas. And so they're always going to be able to hit the y-axis. You'll always have one y-intercept then, and only one. If you can't ever have more than one, because if you have more than one, it fails the vertical line test. It's not a function. So there's always a y-intercept, but there's not always an x-intercept. And if you think about it, you could either be above or below opening away from the x-axis. Then you would have no x-intercepts. Or maybe the parabola just comes and gives the x-axis a kiss. Then you have one x-intercept. Or maybe it actually does cross twice, and then you have two x-intercepts. So these are the possibilities for the x-intercepts. So just kind of keep that in mind when we go through this. So we have different forms for parabolas. There is a form called the standard form. That's what we were focusing before on when we were graphing. Y equals ax squared plus bx plus c. We also looked at the vertex form, which is y equals a x minus h squared plus k. And then there's something called intercept form, which is y equals a x minus m x minus n. Now, if you notice, all three forms have an a. It's the same exact a in both of them. And remember, the a will tell us if the parabola opens up or down. So if a is positive, it opens up. If a is negative, it opens down. And so that's going to be true for all of these. So I'm just going to copy and paste and put this on all of them. But there's some more information that some of these forms say. Vertex form tells us the vertex. Remember, the vertex is always at HK. We can also find the axis of symmetry. which is at x equals h. Standard form, I don't know if you remember, you actually find the axis of symmetry first. So that's x equals negative b over 2a. And then you plug in to find the vertex. So the vertex, the x-coordinate is negative b over 2a. The y-coordinate is if you put this value of x into the function, back into this. Intercept form we haven't talked about yet. So with intercept form, it's called intercept form for a reason, because you can find the x-intercepts. I'm just going to put this here, but then I'll show you why. X-intercepts are going to be at m0, n0. And if you want, pause the video right now and try and figure out why these are the x-intercepts. So let's look at why they're the x-intercepts. Well, remember to find the x-intercepts. You always let y equal 0. And if I let y equal 0 in intercept form, just replacing this y with a 0, it's now in factored form. And we know then you can set each factor equal to 0 and solve. Now, a is a constant. A can never be 0, so that doesn't give us anything. But when we solve the second equation for x, we get x equals m, and this one we get x equals n. So there are the intercepts. So this all gives us a little bit of information. We can find the intercepts for any one of these, though. If we were going to find the x-intercepts for standard form, we're still going to let y equal 0. So I get this, and then it's an equation we can solve. And we can either solve it using, well, we can solve it using any method, whatever's appropriate. Go through the flow chart that we made in class. You know, does the x appear in only one place? You can use square roots. Quadratic formula will always work. If this can be factored, you can solve it by factoring, but it goes back to all the stuff that we've been doing. And then to find the y-intercept, you're going to let x equal 0. And if we let x equal 0, then these first two terms just turn into 0. You get 0 plus c, which is just c. Your y-intercept is always going to be at 0c. For the other two forms, again, to find the x-intercept, we're going to let y equal 0. For vertex form, if you take a look, this is always going to be in this form where the x only appears once. You're always going to be able to use square roots to solve this equation. Use square roots to solve. But to find the y-intercept, we're still going to let x equal 0. So if I let x equal 0, you just plug it in, and you would solve this. Square the h, multiply by a, add the k, you get your answer, whatever it is. And then you would do something similar for intercept form. Still, to find the y-intercept, you let x equal 0. So, sorry, I just lost my train of thought. Weeks. And then again, you work it out. You'd have negative m times negative n times a, and that would be your answer. So then from all of this information, we can come up with pretty good graphs. So that's the lesson right there. I'm going to end it and then work on some examples for you. But then your homework, your classwork and homework today is going to be doing problems that put all these ideas together. So again, look out for I'll put the second video right below this one in the Canvas module. Please be good to the sub, and I hopefully will see you sometime next week, probably toward the end of the week though. But take care, be good, and I'll see you later. Bye.